Chemistry. Today's demonstration is looking at heat of combustion of alcohols. This is investigation 11.1 on page 318 of your textbook. The textbook actually asks you to design your own procedure, so what I'll be doing is just showing you a procedure that works. Now, we need to do this for a variety of alcohols because the purpose is to compare the heat of combustion of different alcohols. So I will be demonstrating this for methanol, and then I will just be giving you some data for the others. So I will do it 5 times for methanol, ethanol, propanol, butanol and pentanol, but there's no point in you watching me do the same thing 5 times. So I will just video myself doing this once, and then I will present you the data so you can do the remainder of it. So you can do the analysis based on the data for the 5 different alcohols. Now, last year we looked at heat of reaction, and we're using the same formula. So this is the delta H equals MC delta T formula, and I'll go through some of that with you a bit later on. You can see the apparatus that I've got here. So our alcohol is in spirit burners. This one is methanol, and we've just got a mini tripod that's been made up specially for this, and a metal can. Now, I've put 100 mils of water in the metal can, and we need a thermometer in there to record the initial temperature of the water, and we need to measure the initial mass of the spirit burner. So we need to know how much has actually burnt. So I'll just put that on the balance now, and that is 192.01 grams. And I'll put that back underneath here, and our water temperature is 22 degrees Celsius. And I'm going to light the wick there and allow that to burn. I'm going to let it go until the temperature goes up about 10 degrees. So once I extinguish the flame, I will need to just keep stirring it a little while to make sure that the temperature that I record is actually the maximum temperature that is reached. Now, I'm using a metal can rather than a beaker for this because metals are much better conductors of heat. This is an experiment where the sources of error are enormous. We will not even get close to literature values. No matter how carefully we do this experiment, we're not going to come close to literature values because there is just so much heat loss to the surroundings. So some of the ways we minimise that heat loss to the surroundings, well, one way is by using a metal can rather than a beaker. I've also got a lower than normal tripod so that the beaker is actually closer to the flame. Now that's getting pretty close, so I'm just going to use the cap to extinguish that flame, and I'll keep turning that. Temperature is still rising. It's up to about 35 now. So okay, 35 degrees is the maximum temperature reached. Now I know that's the maximum temperature because it is now starting to go down. So that lets me know that all the heat that has gone into the can has, well, as much as is possible, has gone into the water. Now I'm going to weigh the burner again afterwards, and it is 191.40. Okay, so I will continue working through this for the other 4 alcohols, and I will give you a set of data that you can use for your analysis.